If we drop a piece of wood and a piece of stone of the same mass but different volume into water, what will happen? The piece of wood will float while the piece of stone will sink. But they are of the same mass. Why does that happen? This happens because of the difference of density. But what is density? Looking at these parking lots, forests, which ones are denser? The ones on the left or the ones on the right? It is obvious that the ones on the right are denser than the ones on the left because there are more objects in the same areas. In the same amount of space, if there are more things, we say that is denser. Density is a measurement that compares the amount of materials an object has to its volume. Density is the mass of an object divided by its volume. An object with a lot of matter in a certain amount of volume has higher density. An object with less matter in the same amount of volume has lower density. Mass is commonly measured in kilograms and grams, while volume is commonly measured in cubic meters and cubic centimeters. Hence, some units of density are kilograms per cubic meter and grams per cubic centimeter. Coming back to the example, why does the piece of wood float while the piece of stone sinks? It has something to do with the density of water. If the density of an object is lower than the density of water, which is 1 gram per cubic centimeter, then the object will float. If the density of an object is higher than the density of water, then the object will sink. The density of wood is lower than the density of water, hence it floats. The density of stone is higher than the density of water, hence it sinks. Hang on, then why can a ship float even though it is made of metal, which has a higher density than water? That's because most of the ship's interior is filled with air. The density of air is much lower than the density of water, which reduces the average density of the ship. So the average density of the ship is still lower than the density of water.
The great Greek mathematician Archimedes, probably most well known for his Eureka! Eureka! Exclamation, once said, "Give me a place to stand and a lever long enough, and I shall move the earth." The quote describes the fundamental principle behind the lever, one type of what we call a simple machine. Simple machines are basic devices that reduce the amount of force required to do the work. Simple machines have been known since prehistoric times until today, with the advantage of carrying heavy things from place to place. In this lesson, we're going to look at 3 types of simple machines, which are the lever, the pulley, and the inclined plane. First of all, the lever. A lever is used to lift a heavy object at one end while a force is applied to the other one. The lever uses a fixed support known as a fulcrum. If the fulcrum is placed close to the object, less force is required to lift the object. If the fulcrum is placed far from the object, more force is required to lift the object, but the object will be lifted higher. Examples of levers include wheelbarrows, seesaws, and bottle openers. The fulcrums may be placed differently in these cases, but the principle stays the same. The next type of simple machines we will have a closer look at is the pulley. A pulley has a wheel with a grooved rim in which a rope is pulled down to lift heavy things up. An object to be lifted is tied to one end of the rope, and a force is applied to the other end by pulling the rope downwards. The force needed to lift an object equals the weight of the object. If more pulleys are added, the amount of force needed will be reduced. In that way, the much easier the object is lifted, although it may take a little more time to lift. This kind of pulley is called the combination pulley. Perhaps the most obvious application of pulleys today is their use in elevators. Imagine high-rise buildings without them. It wouldn't be so great, right? Look around you, and you might see more pulleys than you think there are. Another simple machine widely used is the inclined plane. An inclined plane is a flat surface where one end is higher than the other. It allows things to go from a low point to a higher point, or vice versa, over a long distance. The sloping surface of the inclined plane supports part of the weight of the object as it moves up the slope. As a result, it takes less force to move the heavy object to a higher position, but the object must be moved over a greater distance. However, moving things to a lower position by an inclined plane saves a lot of time and efforts. Slides, roller coasters, and ladders are just some applications of inclined planes in real life.